1 o'clock. Heartily welcome to every participant in this webinar. I'm very glad that we have such a lot of participants from whole of Europe. I see here already now names for me from different gigafactories. Welcome to you. For you, this webinar is partly a repetition, but there are also new information inside. And I see a lot of new names. I'm very happy about all the new participants from gigafactories all over Europe. And I see also a couple of attendees from suppliers and from business partners, mostly from Germany. Also for you, a hearty welcome to our webinar. And I hope you can learn a lot and get new insights into the factory, into the gigafactories and battery manufacturing. This is a standard webinar, so everybody is muted and you have the possibility to use the chats for questions and answers. I have already the first chat here, and it's only a confirmation that you can hear me and you can see me. That's already very nice. And so obviously also the chat function is working. My name is Gabor Sabo. I'm 47 years old. I'm working since this September this year as a sales director for Royma in Europe. I studied economics with a specialization in controlling, which is very helpful for our topic today. And I'm working very long in sales, longer than 20 years, but nearby 20 years I work with X-ray systems and with CTs. So I have already a very good basic knowledge and start understanding what I'm doing here. Royma is a company who is founded in China already 2013. For European relations, it's a very young company. For China, it's a very normal age for a company. We have in China over 250 employees and over 100 from them working in R&D and in construction. This is an important information for you because this is different to European suppliers from CTs and X-ray systems who have normally not such a high capacity in R&D and construction. And this enables us to react very individual for your needs, so we can offer also individual solutions for absolutely reasonable prices. We produce around 200 systems per year in our headquarters in Suzhou. I make a laser, then I can point a bit in our headquarters in Suzhou. And end of this year, beginning of next year, we open a new factory in Beijing. Then we can produce also much more systems than only 200 per year. And we concentrate on the business with the battery manufacturers in China, where we work together not only with the leading manufacturers, more or less with all manufacturers. And you will see it in these presentations that we are really concentrated in the battery manufacturing. And in this presentation, I also try to give you some hints and insights into the information I get from the manufacturing in China, because this is an important point I get from you in our discussions, that you are really keen on and interested in the information how the Chinese manufacturers do it. And perhaps I can help you to shorten your ramp up or your planning from your production line a bit with the information I give you. Here in Germany, we have our office in Hanover, and we have also a demo unit here. It's a standard system. It's not such a special inline system what we have here, but we can make tests for you here in Germany. We can make contract inspection for you, and we are at the moment 2 salespeople in Europe, and will extend in next year to more employees. Here you see an insight into the factory only for the people who are not so used to travel to China. What I also registered in working with you in the gigafactories, that the typical process engineer from a battery manufacturer is used to travel to China very often. So for you, it's a very common inside in such a factory. But for all of you who are not working so often in China, it's perhaps interesting to see it. It's only one page here. You see the production hall from also one of the production halls in Suzhou. And this is the part of the application center and demo center in Suzhou. And that's me working with the Chinese application engineers. And this small fun fact for you that I am the only one person at Royma who doesn't speak Chinese. So this is a very, yeah, mostly funny situation. And it's also new for me to work like this. Important also that you get an insight into our references. Here you have some well-known companies from the battery manufacturing, but in China we work also in other branches like electronics and also castings and aerospace and automotive. What you also register here that we have mostly Chinese companies as a reference, and this is clearly the situation at the moment that Royma is very, very strong in China, in the business in China. In Europe, we start now with my person, and I hope that we can add your names from your companies in the future also to our reference list. And also important information for European customers. We have nothing super special in our system, so it's not so exotic as you believe, perhaps. We work with the standard components in our systems from Comet X-ray Works and also Finetech. We use also Varex detectors, and we work in the standard applications with volume graphics in the analysis. In the inline applications, we use typically our ARM software. And here you see an overview about our standard systems. So we start with a or with a range of small desktop systems with different sizes. We have systems who have a very high resolution in the nanometer range. We have such standard laboratory systems in the range from 225 up to 450 kilovolts. And we have also X-ray systems, for example, for PCBA inspections, such standard inspections. What is already a bit special is such a laboratory system as a gantry system inside. This is not a topic for today, these laboratory systems, but perhaps also interesting for you to know that we have also very special systems. Topic for today is more our inline, our inline capacities. And as you see here, you see again and again the name gantry. After this meeting, you will know exactly what we mean with gantry, and you get also insights about the plannings of the productivity, also a real task about the productivity on the next pages, which is the topic for this webinar. We have also, of course, inline solutions and robot solutions. And here you see a small image for a 6 mega electron volt system. But these are very, very special, very individual systems. So there's no brochure available or something about it. Here you get the first insight into the battery manufacturing and the use of systems there. And even if you use an inline CT or inline solution from us, there are much more positions in the battery manufacturing where you use CTs. It starts already from the incoming products and the raw material that you can check, for example, for foreign bodies. Also here you see a check for particles, in this case directly on the electrodes with 2D. Then we have here our inline systems. We hear more about them on the next pages. And of course, we use the standard laboratory CTs, which are all possible to work together with robots to scan also a whole cell or whole module. So the inline system doesn't replace fully the other CT systems. It's an add-on. And you see on the next page is also some figures that you understand how you improve the productivity with such an inline 3D system. One question I get very often from you, and that's why I have here one page with the answer for you. I get very often the question where the Chinese manufacturers use the inline CT systems, especially for the overhang detection, but also for crinkle and foreign bodies and measurements of the distance between electrodes and the can and so on. And the most Chinese manufacturers use our systems after the canning and after the welding, because while you can and weld the prismatic cells, you can get further damages into the cell. And if you check after the welding, you have a chance to find these damages. Some of the Chinese manufacturers also use our systems before the canning. Here it's not 100% sure why they do it. There's one point you can scan before the canning a bit faster with the systems. That's true. And I guess because these are the real big manufacturers, I guess they simply make experiments in single production lines to see the effect if you scan before canning, after canning, before and after canning. Also, this we have in China. Our recommendation is to scan after the canning and after the welding. Here you see an image from the system. The main image from the system is not so interesting. This is simply the beam safety cabinet. Inside the system, you have such a gantry construction. You get more information about this in the next pages. It's a very special made system. It's made especially for prismatic cells and developed together with CUTTL. It's a three-dimensional CT computer tomograph, and it is developed to make a 100% inline detection and analysis and to work 100% automatic. We can get a throughput up to 36 cells per minute, even if we scan all four corners of the cell. And this figure is absolutely sufficient because the most of you or all of you use downstreams with a speed from 12 up to 24 cells per minute. So I never found the application with more than 24 cells per minute at the moment. The resolution and accuracy is absolutely sufficient for the task, what they have to do. And we can scan also bigger samples up to 800 millimeters. These are the special plate cells from BYD. And also these figures with the 250 millimeters are not super fixed. So if you have a sample which is 55 or 60 millimeter wide, bright, we can also scan this sample, and also here the 200 millimeters are not a deadline. Also, if your sample is a bit wider, we can scan the sample. The sample weight with 5 kilograms is absolutely sufficient for all standard prismatic cells. Why CUTTL started development with Royma for a 3D system? Also, CUTTL used in the beginning inline 2D systems. They have the advantage that they can easily get a very high throughput, but they have the big disadvantage that you have a high misjudgment rate with a lot of false positives and a lot of missed failures. That's why very typical, especially in the beginning of the production and the ramp-up phase, is that customers in China used at-line 3D CT, and also in Europe, the plans from a lot of gigafactories is to use in the ramp-up phase in the beginning a lot of at-line CTs. The advantage is from the at-line CT that you have a high accuracy, but of course a very low throughput. And yeah, we discuss at the moment also plans to use several machines, several CT machines at-line. And here we have to go really in the details in the next weeks if this is really necessary or if we can reduce the number of at-line CT and replace them with inline CT. This will be an interesting discussion in the next weeks. Together with CUTTL, we developed the inline 3D CT which combines the advantages from the high throughput from the 2D systems with a low misjudgment rate from the 3D systems. And you get with these systems a very fast ROE. As I told you on the next page, to get more information about the return of investment. There are also disadvantages, of course, from the system. It has a bigger footprint than a 2D system, so you need more space in the factory. And we scan with the inline 3D systems only the edge of the cells and the upper end and the lower end from the cells. So typically we don't scan the whole cell with the inline 3D CT. So there is still the use or the necessity to make statistical process controls with at-line CTs. Here you see some 2D images simply to see where are the problems and why you have a high misjudgment rate with the 2D CT. The 2D CT is very fast, but have the big disadvantage that you look always only from one direction through the prismatic cell or through the edge of the prismatic cell. And depending from the direction, you have limitations in what you can see and what you can analyze. And here you have a very typical limitation for us, for the human eye and human brain is it is very easy to analyze this image and to see that for this cathodes already looks. I'm not 100% sure if they are okay, but I would say they are okay. The overhang seems to be okay. For an automatic analysis, such an image is extremely hard, up to impossible to analyze correctly. And in the end, it can happen that you sort out the prismatic cell, even if there is no damage or no failure inside. Also here you have an image which is very hard to analyze for an automatic 2D system, and also here you have a kind of an image where you see that it is simply hard to look through it and to make a clear decision if it is okay or not okay. I told you that in China, and this is also a special information from China, the gigafactories can always all for edges, and they have the failure. And if they have the failure, we have to expect that we have the failure in Europe too, that only an edge of the prismatic cell is folded, like you see it here in this image. Here in this case, the cathode is folded, and you see the electrode by themselves is lying quite perfect over the other cathodes, but you have these problems with the folded edge, and that's why always in China the customers scan all four edges from the cells. Here in Europe, I got the approach in the last 2 years from the customers that they have the idea or had the idea only to scan two diagonal edges to see if the electrode is lying a bit wrong or a bit tilted, but you wouldn't see such a folded edge if you are looking in the wrong edge with the analysis. So this hint from us from the beginning, start to plan a four-edge analysis from the electrodes. So now we go a bit more into a scientific approach from the comparison from 2D to 3D, and then we go really to figures. What you see here is an overview or a kind of show how the 2D measurement works. The red line, the red Gaussian curve, are the measurement results from cells which are not okay. The blue Gaussian curve are the measurement results from good prismatic cells, from in order prismatic cells. And what you see is that the measurement results have a very wide spread, and this lead to false positives if the spread gets the measurement under the threshold between not in order and in order. And it leads to a lot of missed failures because here the measurement simply doesn't register and analyze correctly the failures. Of course, you can change the threshold in one or another direction, but then you doesn't solve the problem because then you have more false positives or more missed errors. And I got the figures from China that between 10 and 40% of all prismatic cells are ejected at the overhang inline checks, especially from the 2D solutions. And the 2D solutions have false positive rate from 10%. So 10% from the ejected cells are false positives. So it means also here that between 1 and 4% of the production is simply false positive and is lost for the production. On the other side, we have also a high rate from missed failures if you use the 2D measurements. With the 3D measurements, you have a dramatical decrease of the false positives and the missed failures. I got here the figures from China that the false positives and the missed failures decrease around 2% each, absolutely for the whole production. And only the decrease from the false positives, about 2%, is already an improvement from the productivity from 2%, because then you process these good cells further in your process line, and you have simply more good in order produced cells, and you have 2% more productivity. Also here I made the remark, these are the figures I got from Royma China. And this is an important information from me to you, and also a question from me to you, that I want to make in the next months more tests together with you and get more information from you with your experience and your figures. Of course, I cannot share the figures for free because we have NDAs with each others and competition issues. But it would be important for me to get a validation or verification from these figures, that I know how valid it is here in Europe. How we make our forecast for the return of investment. And we start with the false positives. And here I was a bit astonished. Some of you have already running production lines or are still in the ramp-up phase. But the simple questions, how many of your cells are ejected from your inline inspection, especially for the overhang, for these questions, I didn't get the answer from you. And I'm a bit wondering about that, because for me it's very clear that you need to know how many cells you eject at the different inspection points. And when I ask you for the ejections, I get also some questions back from you. For example, the questions which kind of stacking the Chinese competition manufacturers use, and how these stacking methods influence the ejection rate. And here I cannot give you a clear answer at the moment. We know that we have a set stacking, a cut and stack, and the fly stacking, which is a very modern kind of stacking. But we have no figure yet from China which stacking causes what for an ejection rate in the inline inspection. And also important is that also the previous process steps have already an influence for the ejection rate. And this is also interesting for me to hear, to learn in the next months, how is the influence from these different process steps and stacking methods for the ejection rate. Important also for the ejection rate is the cell design you have, the thickness of the electrodes you use. This is simply a factor which influences the ejection rate, and when you change your cell design, you will also have an effect for the ejection rate. Important also the kind of pressing you use after the stacking. And I heard also that in Europe sometimes the customers have no pressing. In China, very, very common is to use the hot pressing, which leads to a very stable stack, but have also disadvantages, because from the hot pressing you have sometimes some deformation in the stack. And we have the cold pressing. But the Chinese manufacturers tend to the hot pressing. And of course, important for the ejection rate is the threshold, where you set the threshold. And of course, important, and we have to take also this in consideration, in which phase of the ramp up are you? Of course, when you start, you have a very, very high ejection rate when the production is running and you find the right very parameters for the process parameters, then the ejection rate will be lower. Also, this is something we have to take in consideration. And then, if you count the ejection rate, this is simply accounting, simply count the amount of cells which is ejected. Then we have to check how many of these ejected cells are false positives. And therefore, you can use your laboratory CT you typically have in your factory to test the ejected batch and to see how much of the cells are false positives. If you don't have a laboratory CT, we can also do such tests for you in Hanover. We have the abilities to do that. And then, and this is the final point to calculate the ROE, we make the counter check with our Royma systems in China. There we have such systems and we can test your batches there. And then we have a figure how good our system worked with the batch. And then we have a clear idea for the return of investment. How we make it for the missed errors, for the missed failures. The return of investment effect from the missed failures is not so big like the effect from the false positives, because the missed failures are found normally later in the process, or the most of the missed failures are found later in the process, in later process steps like the formation. But of course, you have to you have production costs on the cells which have already a failure. So normally, if you find the errors in the earlier process steps, you save a lot of money for the process steps. Especially the formation is very expensive, and if you have formation capabilities free for good cells and can produce good cells, then it makes much more sense than producing cells which already have a failure inside. And of course, the risk that you deliver to your customer cells with a failure is higher if you don't sort them out in the production. So how to find the missed errors? One possibility is that you make a statistical check after the inline inspection, so that you simply take out the cells which are not ejected and check these cells if they have a failure, if they are wrong cells. You can do this check, of course, directly after the inline inspection, or you can take out the cells from the end control from your production line. Also, a very efficient way is that you take the ejected cells from later process steps. So if the formation gives you the information, or if the formation gives you the signal that the cell is from, then check the cell and look what is the failure inside the cell. And is this a failure, for example, in the overhang? Then we have a typical missed failure in the inline inspection for the overhang. And so you have a very efficient way to find the cells. And also here, make the counter check with the Royma system. And we would do the counter check, of course, together with the batch of the ejected cells from the false positives. So we have the missed failures, the false positives, and the found failures. And with these figures from you, we can test our system, we get our figures, and then we have a very, very clear basis to calculate the return of investment. If you need my help for these processes to make the statistical analysis and so on, then I can help you, that you don't have to invent the wheel by yourself again. And then it's a bit easier for you. Yeah, and then the calculation, I made this page only for fun. Of course, you need for every false positive and for every missed failure a value. You get a value from your production controlling. I cannot calculate this value for you. And with the values, we can make a simple, formula to calculate the potential for the return of investment and to have a clear figure. And with this figure, it is very easy to decide if it is a useful investment for you to invest in a free inline system, or perhaps if it is not useful. There are more advantages if you use a 3D system instead of a 2D system. You get from the 3D systems much more accurate results, and these accurate results help you, of course, to optimize your process control. So from our gantry inline systems, you get more accuracy, and with the higher accuracy, you have a better control of your process before the inline analysis from the overhang. This is also an important advantage which helps you to ramp up your production and to find the right parameters for your production. And also important point is that you are future-proof if you invest in a 3D inline solution. At the moment, the discussions are running in China, but also starting now in Europe, how to make a certificate about the best practice or about a battery pass or battery quality certificate. And it's to expect that a part of this certificate is the use of a 3D inline inspection. Okay, let's come to the technology by themselves, to the inline systems. You see here some graphics, how it looks like. As you see, it's a big gantry where we use a Hamamatsu source and a digital detector. And here you have, the components of the gantry system. We don't have to read through it. I guess for everybody from you is the working principle very clear. And here I have also a video for you. I have to, hold on. I have to switch off the laser pointer and then I start the video. We don't look through the whole video, it's a bit too long. And it's with the original sound from the Chinese colleagues who make some comments to the production line. And in this case, it's our test line where we make experiments with software, with hardware, with different customer cells. There you see the cells coming inside. We have several pickers inside the system to enable high throughput, even if the pickers by themselves moving slow to secure the cells. Then the pickers put the cells on this round table, and the round table drives the cell now inline the gantry system, the same from the other side, like you see here. And then we make the scan of the edges. And in this case, we have two cells together. So we make with one scan two edges. And very often we can put two cells over each other. So we make four edges with one scan, or sometimes we can also put three cells over each other if the cells are very slim. And here I stop the video because I guess at this point it's already very, very clear how the system by themselves works. Here you see how we scan it. You saw it in the video. We have edge to edge, and we make a field from, in this case, around 64 millimeters. And where we scan a range from 64 millimeters from the cell by themselves. And we make cuts 8 millimeters away from the edge of the cell, where we make the overhang measurements, and we make the measurements in 2 dimensions. And here you see how it looks like in practice. These are customer samples. And you see here also how we play together with inline systems and also with outline systems. In this case, the customer want to scan all four edges, A1, A5, C1, and Z5, but also the welding at the position A2 and A4. And what you see is that we do the edges online with our inline CT. You see the images here. And the welding we check offline in a statistical, with a statistical process control. And you see here how we check the welding. So this is very, very typical in China and will be the same in Europe, that we combine inline and offline CT systems. Here you see how it looks like such an 4 up to 8 second scan from such an edge. This is the original scan quality. You see it's a bit blurry and a bit noisy. We use artificial intelligence to optimize the image, and then we use an analysis which is made from Royma by themselves to analyze the overhang, and you get a data file how you want it in a format how you want it with the results from the scan. And and this information you get into your ERP system or production system, that you can work with these figures. And of course, we sort out the cells which are not okay. Here you see it, how it looks like, also here with real customer cells. That's why I blurred the cells a bit, so you cannot see any details from the cells, and you see how it looks like. And also important for you, we talk always over overhang, but also other defects are possible to check inline. In this case, the customer has sometimes the problem with crinkle in the electrodes, which is also very negative for the performance and the security of the cell. And also here, the crinkle we scan inline, and the crinkle at this position, at the A3 position, we make also outline. Here you see an image from a whole cell, how we do it outline, so you have simply an impression how it looks like. And here you see how we position the cells if we make such a scan in the top of the cells. Okay. Here are only some overviews for you. This is such a test equipment we saw in the video, only with one gantry to make general tests, and also with your batches you send us. Hopefully, we can test with this installation. And this is a typical installation for the customers. Here you see we work with 4 gantries to ensure the throughput. And in this case, we use 2 gantries for the overhang detection, and we use 2 gantries for the crinkle detection. And you see here, in this case, we have 16 or over 16, 8, 16, 32 pickers. And with the amount of parallel working pickers, we ensure the throughput of the installation. Here you see it from above, that you have an idea from the space. And I don't know for what we use this space, but the system by themselves is 10 meters long if we take the entrance to the measurement, and it's 6 meters wide. And here you see another kind of installation. So here we are very flexible, depending from your factory how we make the setup for the systems. And here you see a setup with 3 gantries which work parallel. And here is the production line from you, where we take out the cells. Here also again an overview about the main components. Of course, these are the beam safety cabinets. You have the pickers, the round tables, and the gantries, and these are the main components which we use to configure the installation for you. And here also for your understanding how it looks like, you see an example for such an measurement for the throughput we do in our factory in China. And here you see the single points of the process, the timing. You see the overall timing for one cell, and we have in this case 16 processes parallel, so we come to a throughput from nearby 24 ppm for this application. So very important, and then very close to the end of our webinar, some other applications, and these are applications we normally solve at line. So here you see very important connection between the electrodes and the connector outside of the cell. Here you see, and this is a very typical application, the weldings, which have to be checked always in every factory if the welding parameters are correct or not. Here you see the safety valve. In this case, we have two images, one image from a 2D inspection, one image from a 3D inspection. Both is possible depending from the kind of your cell. And here you see such a sealing wall, which is also scanned and analyzed to check if the sealing process is correct. And here also again some weldings and some assembly overviews. And also this is interesting. Of course, all customers make tests with their cell, and also here the city helps you in the laboratory to look into the test results. So here we are already finishing our webinar. It's already 45 minutes now. I say thank you. I hope you could see any new information for you, helpful information for you. Please stay in contact with me. Please help me to learn also a lot about the manufacturing. I help you with all the knowledge I have and I collect in the regulations of NDAs and competition. And I'm looking forward for our next meetings in the future. If somebody from you need more information and details, then please